Hi students, we're going to look at matrices today, which is actually just the plural for matrix. And as it says here, matrix is an array of numbers. It does represent stuff, but we're just going to start with the basics of how to operate with these. Now they're named by their rows and columns. Now the rows are the horizontal, columns are the vertical, and just like we always put the X before the Y, we always put the horizontal before the vertical. The same thing happens here. So if I were to identify this matrix, it has 2 rows and 3 columns. So you would say a 2 by 3 matrix. So again, the rows comes first and then the columns, because the horizontals precede the vertical. Now, so it's 2 by 3, and when you're looking at notation, let me make this a little bit bigger right here. Each position has a subscript. You don't write it, you just do the numbers. But if I were to say, what's at position A subscript 2, it's the -9. So please remember and please write down that the subscript is row, column. The row goes in front of the column. So this is the first row, first column, first row, second column, first row, third column. So remember, that is the order that it happens, or that it's ordered in. That's redundant. Okay, so here's the deal. We're going to start with adding them. Now, this is defined by addition. What that means is I couldn't take like a 2, 3, 1, 6 and try to add it to a 1, 4. They're not equivalent. This is a 2 by 2. This is a 2 by 1, 2 rows, 1 column. So they're not equivalent spaces, if you will, so you can't add or subtract. And to add and subtract, you have to have the same number of elements in the same arrangement. So here is remember it's rows by columns. So notice that there's 3 rows, 2 columns. So this is a 3 by 2, and this is a 3 by 2. All right, to add them, you just do the corresponding numbers. Adding, subtracting, and multiplying these, or multiplying by a scalar, they're super simple. The 3 plus a 0, see, those are corresponding places in this array, so they get added together. It's 3. 6 and -1 is 5. -1 plus 6, of course, is 5. -3 and 0 is -3. -5 and 2 is -3, and -1 plus 3 is 2. So here I have added those 2 matrices to make one summation of a matrix. Now to subtract, here I have 2 rows, 3 columns, this 2 by 3 by this 2 by 3. So since I have the same structure, I can define this. It is defined by subtraction. So that means you can do it. If they were uneven, you would say it's undefined, if they didn't have the same structure there. All right, so same thing. -5 minus 6, -11. -2 minus -5 is 7. -2 minus -6 is 4. 4 minus 1 is 3. Pretty simple, yes? -2 minus 3 is -5. And 0 minus -3 is +3. So I started with a 2 by 3, I subtracted a 2 by 3, and I still have a 2 by 3. Now this is called scalar multiplication, where I'm actually going to scale this up. I'm going to multiply everything by the same factor. And to do that, I'm starting off with a scalar, and I multiply it by everything in this 3 rows, 2 columns, so a 3 by 2. I'm going to get another 3 by 2. 5 times 5 is 25. 5 times 1 is 5. 5 times 1. 5 times -2. 5, 10. And there I have scalar multiplication. And that's it. We're going to leave it there for today. We'll do some work with that tomorrow, and you guys take care.